Welcome to the Like Iron Research Review, a subsection of the Like Iron podcast where we pick an academic article and discuss it. If you enjoy nerding out about strength, fitness, and performance, this is the podcast for you. Remember, research is ever-changing, and our views and opinions will change as well. None of the information in this show should be seen as medical advice, and you should always talk to your medical provider before starting a fitness regimen. Let's get into the cast, Like Iron.
Come paint my face, come take my
Welcome to the Like Iron Research Review. My name is Shannon, and I'm here with my co-host, Wes. Say hi, Wes.
Hello, everyone.
And today we have another paper. This paper, talking about muscles again. We like muscles. Wes likes muscles.
I love muscles.
Mainly just men with their shirts off.
It's my favorite.
All right, and this paper is called, are the hypertrophic adaptations to high and low load resistance training muscle fiber type specific? That was a mouthful. And so is this author's name. This author is Jozo, Grgic, and Brad Schoenfeld. It's Jozo, Grgic. I have no idea how to pronounce that, but it's a cool name. So basically this is not a study itself. It's a current opinion paper, another one by the Brad Schoenfeld lab, I believe. We already talked about how we can get muscular adaptations and hypertrophy from low load resistance training. So this is kind of like looking at the current evidence to see if any of that is fiber specific. Wes, what do we mean by fiber specific? There's other types of muscles. We don't just have muscles.
Yeah, so we'll go into a brief background. And so a lot of you listening have probably heard of fiber types before. And anyone who's taken exercise science or kinesiology or even anatomy and physiology classes, it's probably been taught to you that there are three distinct types. So you'll see, like in humans, you'll see type 1, type 2A, and type 2X. Some of you might have heard of type 2B. That depends on the year of the paper that you're looking at. Type 2B, you'll see in like really old papers, but currently humans are believed to only have type 2X and not type 2B, as in type 2B are found in rodents. And so that's just a little background there. And so I would say that this is kind of misleading how it's been taught, or at least how I was taught, as you have like three distinct camps, and like that's it. Like they're either type 1, type 2A, or type 2X. When in reality, it's more of a spectrum. Like, so you have the spectrum of muscle fibers that can lie anywhere in between, and so they'll quote unquote call them like hybrid fibers. And so they can have, physiological characteristics of a few fiber types themselves, like on that spectrum. What distinguishes a fiber is the motor neuron itself. And the motor neuron, as far as we can tell, doesn't really change. You could, in a lab, you could cut it out and put it on a different muscle, but that's not what you're going to be doing in practice. I hope not. And what can change, at least the current evidence that we have, suggests that the physiological properties of the muscle itself can. And so, this goes back to specificity. So if you train something, you're going to get the adaptations of that thing that you're training. And so if you go from running, and this is kind of how I started, I used to be a runner, and then you switch into lifting, some of those physiological characteristics of the muscle, again, will change based on specificity. And so, again, they can kind of float on that spectrum of those muscle fiber types.
When did you run?
Yeah, you didn't know that? So back in, let's see, 5th, 6th, 7th, all the way through sophomore year, I used to run 5Ks, 10Ks, did a couple marathons that I actually never fully finished. Like bonked out at like mile 18 on both of them, I think. And then did a few duathlons. And then I was like, screw this. I'm going to pick things up. So I don't think I've ran since. But that's how I got started.
Freshman year of college.
Yeah. It was the worst. Yeah. Serious, the same here. But so like what this paper is looking at is, like Shannon mentioned before, we've previously talked about low load and high load, resistance training adaptations as it pertains to hypertrophy and strength. But a lot of the different measuring techniques for hypertrophy look at the whole muscle. And so, for example, you'll see like MRI, which is like the gold standard, has the highest resolution. We see CT, you'll see ultrasound sometimes, but none of those can really distinguish between fiber types themselves. And so this paper was saying, okay, we know that high load and low load resistance training, if with equated levels of effort, lead to very similar hypertrophy adaptations. They wanted to see, okay, are the hypertrophy adaptations of the fiber type itself the same, or maybe are they different? So like with the low load, are we maybe seeing more type 1 growth? And with high load, are we maybe seeing type 2 growth? And that's what kind of got into the purpose of this paper. I guess there wasn't necessarily a specific purpose because it is opinion-based paper. And so they're kind of just investigating a topic and then, giving a current opinion or trying to fill a gap in the research. Like in this case, at the end of the study, they basically conclude like we need more evidence. Right? It was just kind of making a point that we don't really know, and we need more evidence at large to make any distinct conclusions. Anything you have to say to that, Shannon?
No, just I mean the paper it clearly needs more evidence because the whole paper is just like very mixed results. And the problem with a lot of it is those old low load studies weren't taken to failure, right?
Yeah.
So like old studies would say, oh, you're only getting like hypertrophy of these muscles, these fiber types with high load. Well, that's because that low load wasn't taken to a high exertion. And so you're not seeing much hypertrophy with that. Other than that, like the results seem pretty like you're getting hypertrophy of both types, no matter what type of load you're using. It seems like.
So to go back to like what Shannon was saying, they talked about a handful of papers in this study that looked at low versus high load training and then did some sort of biopsy so they could actually analyze the fiber type themselves. And like Shannon was saying, some of the earlier studies that they're mentioning, for some reason, the high load group, had a much greater level of effort than the low load group. So the low load group was doing like super submaximal percentages of their 1 rep max, but also not even taking anywhere close to failure. So it's like, that's going to be really hard. It's like super biased towards the high load group anyway, And so if we're trying to look, if we know that effort plays a huge role in hypertrophy and one group had a high level of effort and the other group had like no effort, then it's really hard to take anything away from that. And then some of the other studies that they're talking about, there's like maybe, when effort was equated, maybe type or low load resistance training favored type 1 muscle growth a little bit more than type 2, and type 2 favored or high load favored type 2 muscle growth just a little bit more than the low load. But they were pretty clear in here that we need more evidence. Like it's really hard to make that distinction. And it wasn't even that big of a difference. Like they were like both low load and high load. You saw really similar type 1 and type 2 growth in those between those two groups. And so, really what this opinion paper is concluding is we need more evidence, and we need more evidence in light with the current training recommendations that Schoenfeld has really put out, which is, okay, if we're going to do low load and high load, that's cool, but let's make sure that both are taken really close to the same level of effort, and let's do what we can to equate volume load, so they're doing similar volumes with similar efforts.
Yeah, and they mentioned this, and it's kind of a limitation with a lot of exercise science papers that I think all of these papers, or maybe most of them, but maybe one, were done on untrained individuals. We know that based on training history, like the kind of like adaptation environment of a person changes a lot as you train, right?
Yeah.
So they did say they looked at one paper which had people or had subjects with an average of 4 years of training experience, and that one found pretty much equal rates of growth. So again, it's like we don't really know, especially like in trained versus untrained people.
Yeah.
So all that taken into account, do you think it's worth worrying about any of this with training, Wes? Like
Honestly,
buying it?
my current opinion, which is subject to change, but currently, I don't think it is worth worrying about this stuff. I think the things that you need to really consider is specificity of the task at hand, and then I wouldn't necessarily worry about training the fiber type itself. I would say, one, we don't really have good data to suggest that you're really preferentially training one more so than the other, in terms of like this paper with resistance training. And so I think that you should be worrying about, I would say, the task or the movement itself, like the specificity of that. And then I also think that, again, this paper is a hypertrophy paper. And so these are usually really useful for physique sport athletes like bodybuilders and stuff like that. And it's like, okay, what you should be worrying about is somehow progressing over time, taking your workouts to, with fairly high levels of effort and doing so, in an intelligent way. So you're not always training to failure, because that's going to, lead to some issues. But also not just sandbagging it, in the gym and never really training, close to failure. And so I think that, practical application wise, one thing that I kind of want to make a distinction here is a lot of us in exercise science, or a lot of people who just go to the gym in general, have always kind of heard like, oh, the hypertrophy training range is like 6 to 12 reps, right? I'm pretty sure almost everyone's heard that. When in reality, it's like, that's not a bad suggestion, but I think it's incomplete or somewhat misleading, because like we also have evidence to suggest that hypertrophy can occur in very high and low, repetition, I would say, groups, if again taken somewhat close to failure. I just think that that would probably be the thing that guides your programming, is picking the movement of the muscle that you're trying to grow, training that movement so you can get better at that movement, and then also progressing over time, rather than saying, oh, am I actually training one fiber type compared to another fiber type?
Yeah. And I think it matters even less when you take into account that a good program over the long term probably uses a wide variety of rep ranges and intensities and volumes. So it's like it's not like you're going to train with very low loads only, or at least you shouldn't be. If your goal is to lift big weights or something, you shouldn't be doing that forever or over a long period of time. You're mixing it up. So
this is where, even in hypertrophy, even though we don't have a lot of fantastic evidence on periodization with hypertrophy, I think this is when periodization can be practical. It's like, if you're going to be training, you could, have different periods of time where you're training in different rep ranges and you're getting exposed to potentially, a different stimulus that might have different adaptations. But as a whole, if you want to have some sort of hypertrophy outcome, it has to be specific to the muscle group that you're trying to train, and also to a high level of effort.
Yeah. All right. So conclusion, we can't really make any good conclusions. It's I don't know. It's an uncertainty, and it just we need more evidence.
Yeah, it's an uncertainty. But the good news is we do still know that hypertrophy can occur with high load and low load training, if taken close, to failure. A lot of this exercise science is always, taken to like momentary muscular failure. And so that's useful for the research, somewhat hard to do, maybe not so practical in training, because if you're always doing that, then, again, you have to think about the fatigue that comes along with it. However, high level of effort and training the muscle will result in hypertrophy. So that's the good news. We just don't necessarily know if it happens more so with one type than the other type.
Mm-hmm. All right. So this has been an episode of the Like Iron Research Review. We'll see you later.
See ya.
Someday you too will go to war, and by that time
Thanks for listening to this Like Iron production. You can find us on Instagram at ShannonDubs, at like.iron_Wes, and at like.iron.strong_Jackson. As always, we love to hear from our audience, so if you have a question or want to chat, drop a line in the comments or hit us up on social media. If you like what you hear, let it be known. Like and review or tell your friends. And as always, stay strong like iron.